Hey guys, we are going to start getting into some word problems using law of sines and cosines now. So this should be a pretty quick introduction to how it's going to work. And then hopefully you guys can just roll with it and start solving problems after this. So the first thing is a lot of times with these law of sines and cosines word problems, they tell you something along the lines of these. We are 32 degrees west of north, or north 32 degrees west, or however it says it. So you need to know how to use bearings and directions, which, that can come in handy one day anyway. So the first thing that's going to be important is for you to know your directions. So on a map, north is up, south is down, west is to the left, and east is to the right. So hopefully you already knew that, and that's just a good little review. If not, that's something you should know. So then whenever you have a bearing such as 32 degrees west of north or north 32 degrees west, basically what's going to happen is, actually I want to draw that a little further over. You are going to start by going north. So we know that you're heading in a northern direction, and then you're going to kind of just swing over towards the west by however many degrees it gives you. So in this case, it's 32 degrees. So you're swinging to the west by 32 degrees. So then I'm going to erase this part where we just went north because we're really going north 32 degrees west. And so our 32 degrees is going to be this angle right here. Is 32 degrees. So if you see something like this, where you're heading 32 degrees west of north or north 32 degrees west, that's how you're going to draw that out. So then I had a few that I wanted you guys to just practice. So if you're doing this at home, try just pausing it here or pausing it after I do one and see if you can get these on your own. And then if you're in class, then I'm gonna pause it and I'm gonna make you do some. So we want to draw the following bearings. So first, I'm just gonna draw a little quad grid plus sign compass, whatever you want to call it, for each of these problems, so that I can go ahead and draw on here. So the first one is 23 degrees east of north. So I would start going north and then I would swing to the east by 23 degrees. So then this is going to be my angle. That's 23 degrees right there. On my second one, we have south. So I'm going to start going south. And then it's 67 degrees west. So I'm going to swing to the west by 67 degrees. And this is going to be my angle. So south 67 degrees west. And my last two, we have 82 degrees west of south. So we would start going south, and then we're going to swing to the west by 82 degrees. So my angle would be 82 right here. And then in my very last one, we have north 19 degrees east. So we're going to swing towards the east by 19 degrees. So this angle would be my 19. So that's kind of how those are going to work out. And then you're going to have to actually draw out triangles based on some of these directions. So let's get into it. So in this one, we have a plane flies 320 miles west of the airport. So let's just start drawing some stuff out. We're going to have the airport is right here. This plane is flying 320 miles west of the airport. So this is 320 miles. Then it turns 23 degrees to the south. So it went 320 miles and it's right here. If it had kept going west, it would still be going in this direction. But it turned 23 degrees to the south. So it's going to turn down by 23 degrees like that. And it flies another 120 miles. So this is 120. And we want to know how far from the airport is the plane. So this is the distance we're looking for. So what we're going to have to do is we need to figure out what this angle is. And it's going to be supplementary to my 23 that I have on the other side. So to get this angle, I would do 180 minus the 23. And I would get 157. And so now I have a side and another side and the included angle. So what we're going to have to do is use the law of cosines to find how far we are from the airport. So what we are looking for is one of the sides. And so that side, I'm going to call it D because it's a distance. So let's just call it D. So for the law of cosines, we're going to have D squared is going to be equal to one of the other sides squared. So let's do our first side that we had, which was 320 squared, plus the other side squared, so 120 squared, and then minus 2 times both of these sides, so 2 times 320 times 120, times the cosine of the angle across from the distance that we're looking for. So it's going to be times the cosine of 157. And so I'm going to type all of this into my calculator, and then that is going to equal D squared. Okay, so I got that all of that is 187,494.77. So that was like D squared it was 187,494.77. And so then to finish solving for D, I'm just going to take the square root of both sides, and the distance would be the square root of my answer is 433 miles, 0.006. So we're going to say 433.01. Or if you just rounded it to 433, then that would be okay. And that would be my distance from the airport. Okay, so y'all have already practiced the law of sines and cosines though, so I did one example all the way through, but for these two, I really just want you to draw the triangles because that's the new part that we're doing today. So if you're at home, again, just pause and try to draw the triangles on your own, and then I'm also going to pause and see if you guys can get the triangles in class. And then unpause when you're ready to see it. So for our first one, we're heading north on our bike and we ride for 2 miles. So we're going north and we went 2 miles. And then you turn on a side road 67 degrees east. So if we had kept going north, we'd be coming up here, but we actually need to swing 67 degrees to the east. So this angle is 67 degrees, and we ride another 1.5 miles. And we want to know how far we are from home. So the distance we're trying to find is this side. And so for my triangle, we're essentially going to have 2 for one side, 1.5 for another side, and then the supplement of 67 for our inside angle. So it'd be 180 minus 67, which would be 113 degrees. So that's going to be my first triangle, and then you would again have to use the law of cosines to find that missing side. And then on our last one, a bus is driving south 44 degrees east. So it's heading, let me draw out the compass again so that you guys can see it. And it's heading south 44 degrees east. So that means that this angle is 44 degrees. And it heads in that direction for 10 miles. So the length of this side is 10. Then it turns due north and drives another 8 miles. So it goes due north and it goes another 8 miles. And we want to know at that point how far it is from its starting point. So we're looking for that last side there. So at this point, there's not a whole lot of information that we have on this, but we can find that inside angle using a property from geometry a while ago. So since we were heading due north when we were going that 8 miles, that's going to be parallel to our original north and south line on the compass. So then since that's parallel and this original 10 miles would be considered a transversal of those parallel lines, we can use the alternate interior angle theorem. And don't worry, you're not going to have to worry about too much all of these theorems, but it is going to help us find this angle here because it's going to be the same as our alternate interior angle here, which is 44 degrees. So then just to draw a cleaner version of our triangle, it would be something like this, where our first initial travel was 10 miles, then we went 8 miles due north, and the angle in between them is 44 degrees. And the missing side you would be looking for is there. So you would use the law of cosines on this one as well. And that really is all that I wanted to try to do in this video, is just show you how to set up these triangles to be able to solve the problems. And that's what you're going to be working on tonight.